about the steam turbine, that is the Rankine cycle, and how Rankine cycle works. First of all, it is to be known that Rankine cycle is a vapor power cycle. It means a vapor is being used to get work done in the turbine. So generally it is the steam, means the vapored form of water is taken for doing this thing. We can see in the Rankine cycle there are four basic components, that is the boiler, the turbine, the condenser and the pump. So let us start from the boiler. In the boiler, liquid water has been fed and heat is supplied to this liquid water. So what happens? This water then converts into high pressure steam, that is the superheated steam, same as like that of our steam formation inside the pressure cooker. By the formation of steam, the enthalpy of water increases. So let us suppose that steam is coming to the nozzle from the boiler with enthalpy H1. When this steam passes through the nozzle, then the enthalpy of the steam converts into kinetic energy of the steam. So what happens? The velocity of steam becomes very high and it hits the blades of the turbine. You can see that inside the casing there are blades which are rotating about an axis, that is the shaft. So what is happening? This high velocity steam strikes with the blade of the turbine, so it starts rotating the turbine shaft, because the blades are rotating and they are mounted over the shaft of the turbine. When the steam do work done over the turbine blades, then it comes out from the outlet of the turbine with enthalpy H2. Now this steam, this used steam is then sent to a condenser where it is being cooled and again converted into water. We can see that steam is entering inside the condenser, it loses heat and then again converts into liquid water, and this liquid water is then again sent to the boiler where it is again heated and formed into superheated steam. This superheated steam is fed to the turbine where it rotates the turbine and do work done on the turbine shaft, and then the exhaust steam coming out from the turbine is then sent to the condenser. In the condenser, the steam is then cooled and again converted into liquid water, and this water is then pumped to the boiler again. This is how the Rankine cycle works. We can see in the boiler the water is in liquid form, which is then further converted into superheated vapor, and then this vapor is then again converted into liquid water in the condenser. So in Rankine cycle, which is a vapor power cycle, there is continued conversion of liquid water into vapor and then vapor into liquid water. So let us suppose that at the outlet of the turbine the enthalpy is H2, and when it is fed to the condenser, suppose heat lost by the condenser so that this steam converts into water is Q2. So coming from the condenser, let the enthalpy is H3, therefore H3 will be less than H2 because some amount of heat is being lost by the steam. Now the pump is taking this liquid water at low pressure and then forcing it to the boiler. So since pump is doing work on water, so the enthalpy of the water will increase, because in this case work is being done on water, but in the condenser heat is being lost, so enthalpy will decrease. Similarly, the enthalpy at turbine inlet, that is H1, is greater than the enthalpy at turbine outlet. Why? Because some amount of enthalpy will convert into the work done of the turbine. Now what is the purpose of rotating the shaft of the turbine? See, this rotating shaft is having angular kinetic energy with it, or simply having power with it. So what is happening, in case we connect this shaft to an electrical generator, then we will get electrical energy. Similarly, we can use the power of shaft for any mechanical purpose where power is needed. At any component of Rankine cycle, we can get the energy interchange only by getting the difference between the two ends of enthalpy. For example, in this case, what is the work done by the turbine? It is simple. See, steam is entering with enthalpy H1 and exiting with enthalpy H2. So steam is entering with enthalpy H1 which is greater than H2 because some amount of enthalpy will convert into work done of the turbine, and the steam will come out from the turbine with the left enthalpy with it. So the work done, the specific work done by the turbine will be H1 minus H2. Similarly, in case we want to know that how much heat is being lost by the condenser, we know that steam is entering inside the condenser with enthalpy H2 and coming out with enthalpy H3. Since some amount of heat is being lost of the steam, so definitely H3 will be less than H2. So the amount of heat lost, specific heat lost from the condenser, will be the difference between the enthalpy at the two ends, that is H2 minus H3. Similarly, work is done by the pump, so it is raising the enthalpy of liquid water from H3 to H4. So net amount of specific work done by the pump will be H4 minus H3 because H4 is greater than H3. Similarly, water is entering inside the boiler with enthalpy H4 and coming out with enthalpy H1. So the net amount of heat addition inside the boiler is equals to the difference between the enthalpy of steam exiting out of the boiler and the liquid water getting inside the boiler, that is equals to H1 minus H4. For turbine expansion, it is to be noted that ideally it is isentropic. It means between point 1 and 2 there is no entropy change. It is because entropy change in a system can only take place in case there is heat addition or heat removal from the system. The expansion in the turbine is isolated and no heat is being supplied to the turbine or taken out from the turbine. So ideally the expansion in the turbine of steam is isentropic, and it is due to this expansion the work is being done at the shaft of the turbine. Similarly, the work done by the pump is also isentropic because pump is supplying the work done and no heat interaction with the pump system of Rankine cycle take place. So between 1 and 2 there is no entropy change. Similarly, between 3 and 4 there is no entropy change.